Hello and welcome. In today's video, I will cover two subjects, which are PCB designing and 3D modeling. I'd like to say a big thank you to PCBWay for sponsoring today's video. As you might have guessed, the project for this video is related to USBs. I'd like to showcase how you can design your own PCB and make a fun 3D model that will house it. We will begin by downloading a program called KiCad. The link for it will be in the description. It is a free program that you can use to create your own custom PCBs and get PCBWay to manufacture it for you. Once you open up KiCad, you will first need to begin by designing a schematic for your PCB. Select the schematic editor. On the right hand side, you'll find tools that will allow you to draw and place components on this workspace. The board I'll be making will be a USB bridge that looks similar to what you see in the picture. Note, the picture is just a concept and not really a final design. Now, to begin adding components, press A and you'll be prompted to this window that hosts a huge library of electronic components. Since we're dealing with USBs, search for a USB component. I'll be going with this old school USB-A for this design. Place the component approximately where it will be located on the PCB. Right-click and select Properties, and now we'll need to assign a footprint to this symbol. A footprint corresponds to the real-life components that manufacturers like PCBWay will use to build your PCB. On the right side, you'll find a 2D drawing of the component. I'm sure a lot of us are familiar with this particular one, and that's what I'll be using for this design. Once you selected your footprint, it will now correspond to the symbol that's placed on your schematic. You can select and copy this symbol if you need multiples of the same part. One problem with having an asymmetrical part like USB-A is that the pins do not line up if you have them facing from one another. What we'll have to do is essentially rotate and flip this USB-A on the other side of the PCB. You can do so using these tools found on top of the toolbar. Now click W to add a trace to your PCB and make a connection between the two USB-As. You'll need to make a direct trace from V-bus pin, D negative, D plus, ground, and shield. The shield portion of the USB is a little bit tricky and requires a resistor and a capacitor to be added to the circuit. This will help to eliminate the potential noise, interference, or even damage to components. You can find a symbol for resistors and capacitors by browsing through the symbol library. As for assigning the footprints for these components, usually a 0603 size parts are commonly used due to their small size, which is great when we're dealing with small circuit boards. The 0603 number does actually mean something. It's the imperial size code, which refers to 0.06 inches long by 0.03 inches wide. Or if we use the metric system, this will translate to the part being 1608, which is 1.6 millimeters by 0.8 millimeters. We need to place the resistor and capacitor as close as possible to USB port. The reason behind it is because their job is to protect the USB against high frequency noise and electrostatic discharge. If they were placed too far away from the USB, then they may lose their effectiveness and the PCB may suffer damage from ESD. You'll connect the USB shield to resistor and then to ground, and then shield to capacitor to ground. One of my favorite tools in KiCad is ERC, Electronic Rules Checker. This will show you if you've done something wrong in your schematic. Right now, what you're seeing on the screen is that the program is telling me that there is no power source being connected to the USB, so we have to add power flag symbol and attach it to the V-bus pin and the ground pin to eliminate this error. As for the other errors, it mentioned that my traces were not properly connected, so just redo that part if you come across this problem. Once you fix your schematic, double check by going back to the ERC and see if any problems persist. Fix them before moving on to the next part. If everything is okay, we can now switch to PCB editor. Click this icon on top of the toolbar. You'll be switched to a different window. This is where your footprints are now 2D models of an actual physical shape of what you'll expect to find in real life. This helps you because you can then shape and form your PCB around the components and move them around as needed. Take a look at this USB component. It actually tells you where the PCB edge is going to be. Pretty cool. Now, as mentioned previously, we need to flip one of the USB-A's on the other side of the PCB. The reason behind it is if we don't do it, the pins will not line up and we can't properly run our traces. Select the USB and click F to flip it. As you can see from the guides that show us where the traces need to go, they actually now line up. To run the trace on the other side of the PCB, you'll have to first start running your trace and click V for via, which will create these tiny conductive holes that allow you to run your trace on the bottom side of the PCB. Continue adding traces as per your schematic. Remember that now all your placements will represent how they will look like on the finished product. This design is completely yours, and when you do upload it to PCBWay to manufacture, that is how they will do it as per your design and instructions. They may also offer you substitute components that should be of equivalent build. Just as the schematic has an electronic rules checker, PCB editor has a design rules checker. This will tell you if there's a problem with your design, if any connections are missing. In my case, where I placed the physical layout of the PCB is on the wrong layer. You change the layer by selecting your outer edge of the PCB and right-clicking Properties and then selecting the Edge Cuts layer. Run the DRC again to see if the error is now gone. We can now begin exporting the design. You'll need to export the bill of materials. PCBWay will need to know what components you've chosen for your design. Component placement file, which will show the position of the components on the board. That's why I mentioned you need to be as accurate as possible with your design and where you want the components to be. A drill file, which will showcase positions of any hole that you made on your PCB. Gerber file, which tells PCBWay where to put your copper traces, silk screen, solder masks, and the board outline. Once all the files have been exported, you can create a singular zip file so you can easily share it with PCBWay. Click the link in the description to head over to PCBWay. You'll also get a $5 new user free credit. Then click Quote Now, upload your Gerber file zip folder. You can also preview your design, how it looks like in their online viewer. Here you can customize your PCB even more by selecting the thickness of your PCB, what color of solder you'd like PCBWay to use for your circuit board. My favorite part is that they offer assembly services, so you don't have to solder anything yourself. Just let PCBWay do it for you. Then proceed to request a quote, and then somebody from PCBWay will contact you with pricing and any questions that they may have about your design. For the 3D model part of the video, I'll be using a program called Plasticity. Plasticity is a type of CAD program used in hard surface modeling. Note that it is a paid program, but they do have a 30-day trial. I'll begin by creating the shape and size of my USB bridge that I made in KiCad. I can do so by using a rectangular tool and then selecting the face of it to extrude it to the thickness of my PCB, which was 2 mm. I will then use a line tool to create pylons and suspension cables. By selecting the curves, I can use the pipe tool by pressing P, which will turn the curves into cylinders. You can adjust the diameter of the cylinder with a menu at the bottom left. I copy and pasted the 2 pylons. I made sure to intersect where PCB will sit. Lined up the suspension cables and made sure that pillars are a little bit higher than them. By selecting these curves, you can click P for pipe tool, which will then thicken the actual curve and turn it into a cylinder. Now I want to use the actual string, so what we're going to do is use a Boolean tool and create an opening in the pillars for a string to pass through. I also added wider legs for the pylons so the physical print won't tip over so easily. I made sure to use the rectangular piece, which represents our PCB, to cut into the pillars, as this notch will be used to hold the PCB in place. This concludes today's video, which showcased how you can design a printed circuit board and design something fun using a CAD program like Plasticity. I would like to again thank PCBWay for sponsoring today's video, and I'll see you in the next one.